Okay, today I want to talk to you about notes number 21. Oops, that's an interesting thing I had on there. Today we're going to talk about solving equations involving absolute value. That doesn't want to draw, so I'm going to lower this a little bit. Involving absolute value. This comes out of lesson 3-8. Okay. So first thing we need to do is to remember what is absolute value all about. So absolute value simply asks for the distance a value is from 0 on a number line. Now, if you remember the number line, we traditionally see it with a 0 in the middle and positives to the right, negatives to the left. Draw a quick picture of one. So if we have 0 here, we have 1, 2, 3 in the positive direction. We have -1, -2, -3. Now, if I'm asking for the absolute value of, let's say, this number here, I'm asking for how far is -2 from 0. I'm not asking what direction, because that's what the sign indicates, is a direction. Negative means it's to the left of 0. Positive means it's to the right of 0. When I ask for absolute value, I'm just saying how far from 0 are you? And we would say it's 2 from 0. So another piece about absolute value is it can be either positive or 0. Now the reason why they have to make that distinction is because 0 is a weirdo. He's kind of like the Switzerland of the number world. He's neutral. He's neither positive nor negative. He's just 0. So that's why they have to distinguish it. So what is an equation going to look like that involves absolute value? Well, the key around our problems is that the variable is going to be inside the absolute value sign. If it's just a number inside the absolute value, then we take the absolute value. But if it's a variable, we have a whole different thing to deal with. So what we want to do is to isolate the absolute value. Oops. And again, write a little comment here. It contains a variable. So that's what's special about this absolute value. We're going to isolate the absolute value on the left of the equation. Just like I've been trying to get you guys to do with variables. Since he contains a variable, that makes sense. I'm staying consistent. So isolate the absolute value. It contains a variable on the left, and everything else on the right of the equation. So when I talk about left and right, I'm referring to the equal sign, okay? Now, here's what's interesting about this. Because of absolute value, we could either have the number that's inside, or we could have the opposite. there will be, in general, two solutions. Okay. So the reason why we have two possible solutions is that the absolute value of a positive is a positive, and the absolute value of a negative is also a positive. So that's where that comes from. We'll write the answers together in solution set notation. And that is the braces, and the two numbers would be inside. And again, I'm pretty lame at making braces, but it's kind of like a forehead, a nose, and a chin. And then the last piece, which is kind of important, is that the absolute value of a number can never equal a negative. And I'll give you some problems to show what I'm talking about that. Okay, so let's do some practice problems. And with all the problems we've been talking about, directions are going to be pretty much the same in the book. It'll just say solve. And of course, just I add in, so you remember what that means. You need to show all steps. There's not a single step that you're allowed to do in your head if you want to get full credit. And there's reason behind why I'm doing this. And it has to deal with math that you're learning now versus math you're going to be learning in the future. So if we just get in the habit of always showing our work, that's all that matters. Okay? So, problem 1. The absolute value of y equals 17. So, they've already isolated the absolute value excuse me, on the left. We've got a positive number on the right. So what could y possibly be? Well, if I put in a negative 17, oops, an absolute value, I would get 17, as well as if I put a positive 17 inside the absolute value, I would get a positive 17. So the answer, when you see the absolute value all by itself, is that we get 17 and negative 17 as the answer. Now we have two ways to show this. We can show it that way. But if the number happens to be the same number, you can use this plus minus symbol. And you're going to want to kind of get used to that symbol because we'll be using that in subsequent math that we do. All right, let's try another one. We have the absolute value of x is equal to 3. And again, if I put in 3 and take the absolute value of it, I get about 3. If I put in the negative 3 and take the absolute value, I still get 3. So the answer would simply be 3 or negative 3. Now the order of those answers is not important. What is important is that you have both answers. Okay? And just to forewarn you, you don't always get the same number. It's all dependent upon what's inside of the absolute value symbol. So, here's one that's a little bit of a trick. The absolute value of r equals negative 7. Well, remember that last note I wrote? You can never get the absolute value of a number to equal a negative. So, because of this guy right here, bam, there is no solution. Okay, remember that's the symbol that means no solution. There's no number that exists that will allow me to take an absolute value and get a negative. Okay? Alright, so those are the easy ones where they've already done all the work for you. Your job is just to interpret the answer. Alright, let's get a little harder. Oops, sorry. Let's get a little harder. And we have the absolute value of y minus 5 equals 1. So here we have a situation where we do not have the absolute value isolated. So to do that, oops, that doesn't work. We're going to do opposite operations. So the opposite of subtracting 5 is adding 5. So I add 5 to both sides of the equation, and I get the absolute value of y is equal to 6. Once I get there, I can give out my two answers. So here I'll show it with the plus minus symbol. Okay. Another one. We have a negative 4 times the quantity of the absolute value of x equals negative 5. So again, we're going to do opposite operations to isolate the absolute value. So we're going to divide by negative 4, and that makes me a little nervous because of the negative. But if you notice, the other side had a negative, so two negatives make a positive 5/4. Now, is it possible to get a fractional answer? Sure, why not? So my two choices are either 5/4 or negative 5/4. So again, remember you can show the answer either way. Both of these ideas are the same. Okay. Let's get you a little bit more work. 2 times the absolute value of x plus 1 equals 15. So what we talked about is when you have multiple operations going on that you need to do the opposite of adding or subtracting first. So the opposite of adding 1 is subtracting 1. And we get 2 times the absolute value of x equals 14. And then the absolute value of multiplying by 2 is dividing by 2. And we get the absolute value of x equals 7. And then my answers are positive 7 or negative 7. Okay, I think I can get another one here at the bottom. Number 7. We have the absolute value of m over 5 plus 7 equals 42. Now, there's a question somewhat similar to this on the Chapter 3 Quiz 1. And what I noticed is that a couple kids tried to multiply the equation by 5. Well, what they ended up multiplying was only the absolute value of m over 5, the variable over 5, and the 42, and they completely forgot about the 7. When you do something like that, you've now changed the meaning of the problem. So remember the rule is do adding or subtracting the inverse of that first. So the opposite of adding 7 is subtracting 7. We get the absolute value of m over 5 equals, 3, and we get 35. The opposite of multiplying by, or dividing by 5 is multiplying by 5, and make sure you're showing that multiplication up high on the left so that it'll cancel out the denominator. But you can put it down low on the right if it's going to help you do the math more easily. So here the 5's cancel, and we get the absolute value of m equals 25. 15 and 2 is 17. So my answers are positive and negative 175. All right, let's do a couple more. We've got 3 times the absolute value of x equals 2 times the absolute value of x plus 8. Now this one, we have absolute value of x's on both sides. I think I said that right. 3 absolute value of x equals 2 absolute value of x plus 8. So first step is to get all the absolute values of x's on the other side. And we're going to do the same way as if it just said 2x. We're going to subtract 2 absolute value of x from both sides. And then we get absolute value of x equals 8. So my answer is positive 8 and negative 8. Okay. All right, I've got a couple more, and these are the ones where you're going to see something happen to the answers. Last two. Number 9, we have the absolute value of x plus 2 equals 8. Now, on this one, we already have the absolute value isolated. So I can't just say plus or minus 8 because it's not just x in there, it's x plus 2. So what I need to do is think of two cases. We have the positive case, and in that one we drop off the absolute value and we're going to solve the equation x plus 2 equals 8. Then we're going to do the negative case. And the negative case, I'll highlight, is x plus 2 equals negative 8. So the only thing that we put the negative on is the number that's on the other side from the absolute value. And then we go ahead in both situations and we solve. We're going to subtract 2 from both sides in both equations. And we get x equals 6. And here we get x equals, signs are the same, so I add negative 10. So anytime there's math going on with the variable inside the absolute value, you're going to get two different numerical answers. Okay, let's do one more like that. And we have the quantity 2a minus 3 equals 5. Again, two cases. Positive case, we just drop off the absolute value sign, and we have 2a minus 3 equals 5. And then we have the negative case, which is still 2a minus 3 equals, so nothing changes on the left side, but the change comes here with negative 5. So to solve, again, both equations need to get rid of the minus 3 first, so that the opposite would be adding 3. And that gives me 2a equals 8 on the first one, and 2a equals negative 2 on the second one. And unlike the last problem where there was no coefficient on the x, this one does have on the variable. So the opposite of multiplying by 2 is dividing by 2, and we're going to do that to each of our equations. So we get a equals 4 and a equals negative 1. So both of those answers are considered solutions. All right, good luck on your homework.